Welcome. We will start back up with Enddy Dumbrique from Amplica Labs with the title to talk Overcoming Obstacle and Building Unique Economic Models with Polkadot. Welcome.
Testing. Hello? Can you guys hear me? Yes, okay. Ah. Well, I guess I won't be able to take this off because it's stuck to my coat. All right. It's okay. Wow, what happened there? Oh, there we go. Well, welcome to Overcoming Obstacles and Building Unique Economic Models with Polkadot. My name is Enddy, and I am with Amplica Labs, where we're building infrastructure and tooling to develop the next era of social media applications. At Amplica Labs, we are core contributors to the frequency parachain, where its mission is to build scalable, decentralized messaging. Let me share with you what I'm going to be talking about. Today, I'm going to tell you how Amplica Labs is building a decentralized social media network on the frequency parachain, and how share with you some of the obstacles that we face and we're overcoming by building unique economic models. And lastly, I'm going to share with you how this economic models fosters bringing the next wave of Web 2 users to Web 3. Let me start with the problem we're trying to solve. How do we bring user control to Web 2 social media users? To answer this question, I'm going to first share with you some of how we got to a solution that we think is viable that will allow us to bring the next wave of Web 2 users to Web 3. When we first began to think about this problem, we started thinking about how is it that we can include social media in the very fabric of the internet. And so one of the things we started thinking about was building a protocol for social media. We had 6 principles in mind when building this particular protocol. One of them is user ownership, user privacy, authenticity, portability, usability, and extensibility. Now, all these may seem very familiar to you since you guys are in the blockchain space, but one of the things I want to highlight where we really shine is in the usability and extensibility part. After just taking some time to think about how we can realize this particular goal that we have in mind, we started prototyping. We started prototyping initially on Ethereum, and it didn't take long to realize that the cost of and transaction fees are quite high on Ethereum. So naturally, the next thing that we did was think about sidechains, right? When we started thinking about the architecture of sidechains, we started realizing that all we were really doing was essentially cost shifting and shifting from one entity to another entity in the social media ground of participants, right? So we started, and even with sidechains themselves, right? Even though we were able to reduce the fees with cost shifting and so forth, it was still costly to commit to the layer 1. So we started thinking about economic models. And we quickly started realizing that this economic model can get quite complex. So on this layer 2s or on the side chains. So we then shifted to doing more research and started thinking about how we might be able to implement these on other blockchains. So we did some prototyping on blockchains like Near. We did Near. silica. I mean, the list goes on. But we then realize, after this extensive research, that that essentially blockchains optimize for applications that are centered around the transfer of value. And in the current state of social media, posting like a funny cat video, right, or saying good morning, GM, really has zero marginal value. And social media itself really gathers its value from the aggregate of transactions and not like from an individual transaction. So unlike DeFi and DeFi applications or NFTs, right, there is value in that single transaction that you make. And that doesn't work well with social media. These type of what's called data transaction driven, or excuse me, transaction data driven transactions, right, cannot compete in the block space with financial transactions. And high volatility does not work well with building social media. So how do we bring user control to Web2 social media users? Well, our solution was to come up with a different economic model. One that is optimized for non-financial transactions, that make transaction costs predictable and stable, and that is built for collaboration and scale. With a clear vision of the economic model that, with these goals that we had in mind for our economic model, we found that among those blockchains that we researched, that Polkadot was a great fit for us because it's really a canvas for innovation. It allowed us to think about economic model and not worry about the security layer because we would get that from the relay chain. And we were able to build primitives and for data-driven transactions, and as well as provide first-class support for things like delegation. So let's dive a little bit more into what our economic model is. It's really consistent of three models. One of them is the delegation model, second is the data transaction model, and third is the capacity staking model. Dive a little bit more into the delegation model itself. As you are aware, blockchains are complex, right? The more a blockchain gives users options, the more complex it becomes, right? Meaning, the more, for example, the more choices you give a particular user in blockchain, the more it gets complex. And we think we found a bit of a sweet spot with our delegation model, where we allow users to delegate to, for example, service providers, which in turn can batch transactions on a user's behalf. And what this allows to do is be able to create a tokenless onboarders for user, because when a user enters, for example, an app, they can be prompted with granting a service provider permissions. And what's sweet about our economic model is that at any point a user can revoke access, right? And it doesn't cost anything. So while you're able to grant delegation and that doesn't cost anything, it also doesn't cost anything for a user to revoke these particular transactions. And this as well, because they don't have to interact with the wallet frequently, right? They're able to reduce the complexities that wallets have as well, or reduce the amount of interactions with wallets for a particular user. So in the current in the current system, right? And most blockchains, right? They prioritize, right, these financial transactions that have some sort of value to them. As stated before, right? Data-driven transactions cannot compete with these type of like financial transactions, right? And so we have this ability to batch transactions. So again, a user coming through a system, they delegate some authority to a particular application, right? And then this app developer can now batch thousands of transactions. And what's something that is very important here is that these type of transactions can be parallelized. So data-driven transactions, particular social media, does not suffer from like it doesn't have the complexity of the double spending problem, right? Because I can say hello multiple times, and it really doesn't matter. Like I could say hello 10 times or like a million things simultaneously, and it doesn't really suffer. So we're able to parallelize thousands of transactions and batch them and submit them through our system. As mentioned, I guess I already talked about this part, so I'm going to skip through this one. So now, one of the things that I pointed earlier that current blockchains kind of, why current blockchain solution or economic model doesn't work for social media is because of the volatility behind transactions. Oftentimes, right, any volatility in submitting something like a post like hello world or what it is, or a funny cat video, right? Any volatility can disincentivize a particular user from even posting. So a very important part of our economic model is to be able to create some sort of like stability for service providers to be able to encourage them to submit those batches of transactions to the chain. And as well as when we're able to stabilize the price of these transactions, as well as reduce the volatility, right? It becomes a lot easier for an application to be able to know how much they want to transact, or know how much they need to transact, really. And I can. Well, yeah. Let me dive into this part actually before I show you how this works a little bit more. So how do we do this, right? So we have this concept of capacity, right? And you think of capacity as a resource that provides you with an alternative form to transact, right? And when you have capacity, right, what it allows you, what happens is that you're able to acquire this capacity by either someone staking to the network and targeting you as a provider, or you yourself as a business can stake some amount of token to yourself, and as a result acquire capacity. This capacity allows you to transact at a fixed price, right? And what's great about it is that after a certain amount of period, your capacity gets replenished. So what does this look like? I actually have something here that live that we didn't have before, but now we do. I wasn't planning to add this, but I think this is better to show something like in the real world, right? See, what you see here is some sort of provider here who's onboarding users at the moment into our network, and here on the bottom right is their consumption of capacity. And what's neat here is that you can see the service provider kind of spending or using this to transact, right? And as you notice here, there's a huge spike, and it's because they start reevaluating. Hey, we need more capacity because we are posting this much for a particular period. One thing that I didn't mention is that the idea of epochs, right? Epochs is essentially a meta block. So once you acquire capacity, that particular capacity is replenished after a certain amount of blocks, right? So as you can see here, like they're using capacity, and here there's a huge cliff because they ran out of capacity, and then they start consuming because they regain that capacity and so forth, right? And here is like, you know what, we need to be able to have more capacity, right? So that, because we are transacting more often, and so they're able to then now have like, what is my total expenditure that I'm going to need for the whole month or quarter, or be able to scale with the amount of users I have. Cool. Let me, I was going to wait for questions to the end, but I feel like I just talked quite a bit. Is there anything that is confusing here? Or a concept that might be a little bit off? Great. Now let me see if I can put back the other slide. Huh. I should have practiced this part, right? Okay. That worked out, but I lost my notes, so it's okay. Cool. All right, as mentioned, right, how can one acquire capacity, right, to be able to have this particular ability to transact at a fixed cost with stable pricing? Well, two ways. One of them is being able to, some of your, for example, some of your users really like your service, so they're going to like, hey, I'm going to support this particular dApp because they're amazing and I really love the user experience they provide for me. So what they do is then they stake, and again, when I say stake, we're not talking about anything that is staking to Polkadot or any sort of palette that is related to Polkadot. This is a frequency special kind of staking palette that we have here. So I wanted to clarify that. So two ways. One of them, again, as I mentioned, is the users staking to the network and targeting you as a provider. And the second one is you yourself can, as an application, stake and in return receive that ability to transact. When users stake, there's also some reward structure, which I would want to get into because that's going to take me to another avenue as well. Guess I don't need this anymore. So what levers do we have to like remove some actors, right? As mentioned, we have the epoch period, right? The epoch period can be increased or decreased based on network congestion, right? And as well as be able to update these. Let me take a step back because I said something wrong. That is not a lever. When I mentioned right now, it's not a lever for removing bad actor, but it's a lever for managing the congestion that we can incur in the blockchain. But we also have a thought period. So when you stake some sort of amount to the network, right? You can't. There's a period in which you cannot. You have to wait to receive your tokens as a result. And as well as, right, a big important one that is kind of subtle to miss, right? If you're not a great service provider, if your application is not really adding that value, there is no incentive for anyone to really stake to you, right? You want to be a good application and add value. So that is a natural way of like reducing these bad actors, because the alternative is that they would essentially stake some amount of their own currency to the network. And yeah, I mean, they stake it and they really won't gain much from it if they're not adding value to the network as a whole. Let's see. I talked about as well as managing congestion. I got a little bit ahead of myself there, right? And so to manage congestion, we can also increase, decrease the length of this epoch period, right? And there's various ways in which we could play with this. Currently, we have a fixed epoch period, but we have some sort of governance to be able to change that, and we have implemented both of these. But for simplicity, in the beginning, we make the decision to just keep it fixed. So the next section, I'm going to dive a little bit more into the technical aspects of things. I threw these ones in very last minute, so one of the cool things that Sub0 allows you to do is be innovative, right? So one of the things that we have a dual account model. So we don't just have a token model, right, where you use your tokens. We also have what we have accounts that don't require tokens. So we have the tokenless users, right? And these type of accounts, right, are what we call MSA accounts or message source accounts, right? And these messages core are essentially your social identity. At any point in time, you have some sort of keys that are attached to your social identity, right? And now you can also delegate to another account that has an MSA, and all without having any tokens. So this is a very important part. I really think that, if we want to onboard the next wave of Web2 users to Web3, we have to eliminate this kind of idea or facilitate really people being able to want to use an application without acquiring the overhead of acquiring a token. It's much more inclusive when we allow someone to use your application, right, and not require them to have some sort of token. And I really think that is a big key, because oftentimes when your user comes into the blockchain space, in some way they're kind of speculating, right? And it's difficult for a particular user to say, let me spend this particular token around, let me act with this, because there's always that speculative aspect. And I really think that having these two types of models, right, really removes that speculation for user and removes that overhead to allow them to kind of just use Web3, what we're building at the moment. So how do we manage this? So within Substrate, we have sign extensions, right? And as these transactions come in, we quickly essentially able to compare them amongst each other and say, this is a capacity-driven transaction, this is a token transaction, and then we do some sort of validation around that, right? And do some sort of accounting. Cool. And when it comes to epoch period, which is another key component, right, it's really taking advantage of the life cycles that we have in Substrate, right? It's actually quite simple, right? We have an unfinalized, and we check whether this is the end of the current epoch, right? And then we make a decision whether or not this is like a new epoch period or not. And that's the end to my presentation. Again, I really think the way in which we build this economic model, right, by allowing delegation, allowing to batch transactions, or giving authority to application to batch transaction, and not requiring a user to need a token, as well as the pricing, the stable pricing, is really key to onboard the next wave of Web2 users to Web3. That's it. Any questions?
Do you have any question for, no? Okay. Yep.
So with your capacity model, is that automatic? Is there do you have to invoke it specially when you make call on-chain operations? And also, if you run out of capacity, is it an automatic fallback to paying with tokens, or how does that work?
Yeah, I know I mentioned delegation. That's a really good question. I know I mentioned delegation, and some of you may be skeptical to the idea of delegating anything to anyone, right? But you can always be a sovereign user. Meaning, if you really want to like not delegate and still use the system, right? You can always be a sovereign user. As a service provider who has capacity, right? As you saw earlier, right? There was some sort of like you can see this cliff where the capacity just dropped, right? And well, after that your capacity over, you have an option, right? Do you think that you need more capacity, right? Meaning that your business requires you to post, your users are demanding, more batching or more frequent batching, right? This is ultimately a decision that the application needs to make. But you always have the ability to increase that capacity, and I think you saw that like in the slide earlier, where there's a little bit increase in the usage, right? And that is because that particular service provider business require them to be able to transact more frequently. Did I answer your question? Yeah. Any other questions?
No more questions? No. Thank you, Andy.
Woo!
Thank you very much.
Thank you.